Okay, this is the medium problem from section 10, multi-dimensional arrays of the Udemy course, Mastering 4 Critical Skills Using C++17. Basically, we're looking to find so-called mountains within our 2D matrix or 2D array. So for example, in this 3 by 3 square, as shown, our two mountains are at position 0, 0, where 8 is bigger than all values surrounding it, and here at position 1, 2, 9 is bigger than all surrounding values. And basically, if the value in that specific part of the array is bigger than all surrounding values, then it's a mountain. How do we code that? Well, of course, we're going to need our n and m values, which are going to denote the number of rows and number of columns in our array. So the first thing we're going to need to do is input the rows and columns. Now, for using these, we're going to input the values in our 2D matrix. Oops, there's a small mistake up there, you may have noticed. I is less than n, not I extract operator n. So we're going to input I and j, and that should be the matrix filled. However, we're going to need to find mountains, so to speak. So this is where we use something called a direction array to look for in all possible directions of our direction array. We're going to need an I and a j value, because what we want to do is go in every possible direction of the compass around the value we're looking at and see if any of those numbers is bigger than that value. If so, then we don't have a mountain, we're not looking at a mountain. All will become clear in a moment. So a direction array I, basically going up, I is our row, going up from our position. If you can imagine that we have points on a compass like this, this is the value we're looking at. 1 is the value we're looking at here. Going up, we've got -1, -1, -1, and then the value immediately to the right of the 1 is on the same row, so it's 0. The value on the right is on the same row, so we're calling it 0. And the ones below our original value, I'm saying that we're shifting the row up by 1, so it's +1, +1, +1. Our j values, top left is -1, top just above is 0, it's on the same column. Top right is 1, left is -1, immediately right is 1, bottom left is -1, below is 0, and bottom right is 1. Now, how are we going to use these? Well, to begin with, I'm going to take a starting point. Well, let's not do that. Let's do something a bit more simple. We're going to go through each point in our array. J is less than m plus j. So our int value equals I j. Now, so we've got our original value. We're going to want to check this against the value immediate or every value immediately around it. So how are we going to do that? Well, we've got our I and j values. So for example, it's 0, 0 in the first thing we're looking at, and we have a kind of check. Check beginning from 0. Check is less than 8, because that's the number of possible directions. If we're we've got 8 numbers, a maximum of 8 numbers surrounding our input value. Check is equal to 8. Our new I is equal to direction array. Well, I'm going to make it a new I equals I plus direction array I check. Int new j equals j plus direction array j check. So if my array new I new j is well, first of all, before we do any of that, we're going to need a bool to determine if it's a mountain. Our bool will be true. However, if the value that we're looking at using the direction array, any of the values around our value is greater than it, then is mountain will be false. And once we've exited that check, if is mountain, we're going to see out mountain found at I j. Now, there are a few conditions that we're going to need though, because we might go out of bounds. So if new I is less than 0, then continue. If new j is less than 0, continue. If new I is greater than or equal to n, that's our number of rows, continue. If new j is greater than or equal to m, then we're going to continue. So, hopefully, with all of that typed out as it was, we're going to be able to get a successful code here. So, we're going to have a 3 by 3 matrix, inputting 861, 329, 164. If all goes well, we'll have mountains at 0, 0 and 1, 2. And there we are. It worked unexpectedly well.